that's majorly on measurement and quantity. So if you just follow me over time, so we're going to derive units of some quantities. And probably I know we can remember the basic or the fundamental quantities, such as the fundamental quantities. I'll just use short form to explain. The fundamental quantities are actually 7 in number, so I'll just outline them. We have mass, we have time, we have temperature, we have amount of substance, we have luminous intensity, and we have length. Let me see, keep it up to 7. We have 1 mass, 2 time, 3 temperature, amount of substance, 4 luminous intensity, 5, 6, and remaining everything mass, length, time, amount of substance, luminous intensity, and length. Okay, so when I remember the other one, I'll add it up there. So we're going to derive units for the following derived quantities. That is, we're going to solve for density, we're going to solve for pressure. And now, the key to solving this is actually expressing them to the fundamental units fundamental quantity. That's to say, density is a derived quantity, pressure is a derived quantity. Now, to solve this, you have to take them low, express them to the fundamental quantities on which they are derived from. Because you say derived quantities are actually derived from fundamental quantities. They are not dependent on themselves. They are not independent. They are dependent on the fundamental quantities. So we're going to derive the units for density and pressure. Now we're going to take question in the solution. So the solution is this. First of all, the first step is to determine the formula for density. And the formula for density is actually mass over volume. And please don't forget mass over volume. Okay? And we said for us to express this, we need to take them to their fundamental quantities. And mass is an example of a fundamental quantity. See it here. And we don't have volume here. Volume is not a fundamental quantity. Volume is a derived quantity. So I said I was going to add up an example of a fundamental quantity. I said it's 7 in number. So we're going to add up electric current. Electric current. Please pardon me, okay? Electric current. So these are the fundamental quantities. It's 7 in number. On which other quantities are derived from, and they are called the derived quantity. Okay, so the formula for density is mass over volume. I said mass is a fundamental quantity, but volume is not a fundamental quantity. So since volume is a derived quantity, the formula, now we're going to now derive the formula for volume. The formula for volume is equal to, I have to divide this ball into 3 parts. The formula for volume is what? Length times breadth times height. Okay, now since we've gotten the formula for volume, well, we're not going to express it to the fundamental unit. You know, in in measurements, in quantities, we have fundamental quantities, we have fundamental units, we have derived units, we have derived quantities as well. So now the unit of length, length is measured in meters. So we're going to write meter as is probably m times n times m. That is what meter cube. So I'm going to express it. This is meter times meter times meter. So probably this is what it means, okay? Density is equal to mass over meter times meter times meter. Now if you check too well, I said for you to actually solve this, you need to express it down to it being a fundamental quantity, and the fundamental quantities are to what meter. And we know that the unit of mass is kilograms. I said we need to express them to their fundamental quantity. And mass is measured in kilograms. Time is measured in seconds. Temperature Kelvin. Amount of substance mole. Luminous intensity candela. Length meter. Electric current ampere. So now what's the formula for volume? So it's length times breadth times height. And we know that the unit of length is in meters. Breadth meters, height in meters. So we have meter times meter times meter times meter. So what do we do? So density is equal to, what's the unit of mass? Kilograms. And the unit of meter is m. How many m do we have? So m times m will give us is equal to kg over m times m is meter cube. So now for us to express this as a unit, it's going to be density. Density is equal to kilograms. Kilogram meter per cube. So this is what it's going to give us. So how do we get this minus sign? Think of this division sign here. So we have meter. So we have kilograms meter per cube. So this is the unit of density. So therefore, the unit of density, the unit of density is equal to kilograms meter per cube. So if you have questions, you have comments, just go to my comment line, show your questions. We have classroom as well. If you want us to throw more light on what our course, you can just click below.